Hey friends, this video is going to be about square roots and cube roots. Um, so a square number is a number, um, for example, if I have a length of 5 and I have another length of 5, if I multiply those two numbers together, I get the area of 5 times 5, or the square area of 25. So a perfect square is a number that's been multiplied. A perfect square is a number that has two factors that are the same, um, or it's a factor that's been squared. So 25 is 5 squared. To find the root of a square number, or a number that is representational of something multiplied by itself, I'm trying to undo taking the square of it. So if 5 squared is 25, then 25 is a perfect square, and the root of 25, or what got multiplied by itself to get me 25, that root is this base here of 5. Okay? So as I'm looking for square roots, I'm looking to find squares. I'm looking to find factors that have been multiplied by themselves um, to a factor of an exponent of 2. So one surefire way to be able to find square roots is if you take a number, even if you don't know what its root might be, if you take a number and make a factor tree of it, if we can find pairs of factors, or some factor that's raised to the second power, then we know that we can find the root of that square, because it will just be the base of whatever has been squared. So let's try an example. If I look at the number 484, I don't know necessarily off the top of my head what I multiplied by itself to get me 484, but I can find the factors of 484 by just making a factor tree. This is an even number, so 2 has to go into it. So 2 goes into 484 242 times. Well, that's still an even number, so 2 must go into it again. And already I'm sensing there might be some pairs here. But 2 goes into 242 121 times. Well, what goes into 121? It's a palindrome, so that leads me to believe 11 might go into 121. And sure enough, 11 times 11 gives me 121. So if I come in here and I start looking for pairs of factors, I see that I've got a pair of 2's. So in other words, I've got 2 squared. And I've also got a pair of 11's, which are 11 squared. So in other words, the factors of 484 are 2 squared times 11 squared. So if I want to take the square root of 2 squared times 11 squared, I'm really just taking the square root of 2 squared. I'm going to multiply that by the square root of 11 squared. Well, here I have a number squared, the number that was squared here. Sorry, let me undo that. Here I have a number squared, right? The base, or the number that got squared, the number that I multiplied by itself, is 2. So the square root of 2 squared is 2. Here I have 11 squared. And the base of this square is 11. So in other words, 11 squared, the square root of 11 squared is 11. So the square root of 2 squared times 11 squared is 2 times 11. And 2 times 11 is 22. So the square root of 484 is 22. Let's try that with another example. Here, let's try that with 441. So let's do the same thing. We're going to make a factor tree. Goes into 441. Well, 4 plus 4 is 8, plus 1 is 9. So 9 must go into 441. Okay, so 9 9 goes into 44. It would go into 45 5 times, so it must go in 4 times, leaving with 36. So that's 81. 9 goes into 81 9 times. So 9 times 49 are my two factors. So I can break up 9 into 3 times 3, and I can break up 49 into 7 times 7. So in other words, the square root of 441 is the same thing as the square root of 3 squared times 7 squared. And if I ask myself, well, what's the root of 3 squared? The root of 3 squared is 3. And if I ask myself, what's the square root of 7 squared? Well, the square root of 7 squared is 7. So the two roots here are 3 times 7, or 21. So the square root of 441 is 21. I could verify these by multiplying them back together again. 21 times 21. So 1 times 21 would give me 21, and 20 times 21 would give me 420. And so adding those together, I get 441. That was my check. Okay. Let's try one more. Let's try 162. So if I take some factors of 162, well, it's even, so 2 must go into it. With 81. Factors of 81 are 9. Oops, that's not prime. Silly Kate. 9 times 9. And the factor of 9 is 3 times 3. And 3 times 3. So here I've got some pairs. I've got a pair of 3s. I got another pair of 3s. But again, since I'm looking for pairs, I'm actually going to list these out separately. So I've got 2, don't forget this factor up here, times 3 squared, it's my pair, times 3 squared. Now I could write that as 3 to the 4th if I wanted to, but again, since I'm looking for squares, right, I'm looking for a base that I multiplied by itself, I find it easier just to keep them grouped by squares if I can. So the base here of 3 squared, the square root of 3 squared, the square root of 3 squared is 3. And the square root of this 3 squared is also 3. But here I've got a little bit of a problem. Let's take a look at this. So here I've got the square root of 2, but there's no exponent, so this is really 2 to the first power. There's just one factor of 2. So I don't have a pair of 2's here. So I can't really take an integer square root of 2 to the first power. It's not a pair. It's not been squared. So for our purposes, I'm just going to say I can't take that yet. I can't take that square root of 2 to the first power yet because it's not a perfect square. So I've got now, I was able to take the root of 3 squared. I was able to take the root of this 3 squared. I wasn't able to do this part yet. So I've got 3 times 3, which I took, which is 9. But then I've also got this other factor, which is the square root of 2. So the answer to that one is 9 times the square root of 2. Let's take a look at cube roots. So if squares are 2 dimensions, a cube is something that has 3 dimensions that are the same. So we've multiplied 5 for the height, 5 for the length, and 5 for the width. So we've got 5 times 5 times 5, or 5 to the 3rd power. So if I want to find the root of this cube, what was the side length that gave me a volume here of 5 to the third power, or 125, I would say that the root of that cube is the base of that exponent. So the root of that cube is 5. So the cube root of 125 is 5. In other words, instead of looking for pairs, I'm looking for triples. I'm looking for 3 factors together that make up a perfect cube. So I'm going to do exactly the same thing that I was doing before. I'm going to make a factor tree. So let's see if 7 goes into that. So 7 would go in 4, 28, 63, 49 times. And that would be 7 times 7. So here I've got 3 factors of 7. So I'm looking now for the cube root. Notice my little 3 right here, because that means I'm looking for the cube root. On the square root, we didn't put a number there. If we wanted to, we could have put a 2 there for the square root. But now we're talking about the cube root, so we've got this little 3 as our index. This is called the index. Okay, so I'm looking for the cube root now of my factors 7 times 7 times 7, or 7 to the third power. So what's the root of 7 to the third power? What's the base that was cubed? Right? What's the base that was cubed? And the base that was cubed there is 7. Let's try 216. So 216 is even, so I'm going to divide it by 2. And that's going to give me 108. And 108 is even, so I'm going to divide it by 2, which gives me 54. And 54 is even, so I'm going to divide it by 2, which gives me 27. And that's not even anymore, but that adds up to 9. And 9 is 3 times 3. So here, again, I'm looking for not cubes, not squares anymore, not 2 factors. I'm looking for groups of 3. So here I've got the cube root of 2 to the third power times 3 to the third power. So thinking about those bases, the base of 2 to the third power is 2. So the cube root of 2 to the third power is 2. And the cube root of 3 to the third power is 3. So 2 times 3 is equal to 6. And 6 to the third power then should give me 216. 216, the cube root of 216 is 6, because 6 times 6 times 6 gives me 216. Cool, right? Prime factors. They're amazing. They do all sorts of amazing things. Let's try one last one here. Let's try 16. So 16 is even, so if I make my factor tree, that gives me 2 and 8. It gives me 2 and 4. That gives me 2 and 2. And so again, I'm looking for triples. I'm looking for 3s of a kind. So there's 3 2s. So here I'm taking the cube root of 2 to the third. That's my group of 3. But be careful, because I've also got this other, maybe I'll make them blue, this other sort of lone 2 over here, right? Which I'm just going to write as a separate factor. Here's my group of 3. But then I've got this extra factor of 2 in 16. So if I think about what's the root for, again, the wrong color. What's the root for this 2 to the third power? Well, the cube root of 2 to the third power is its base, or 2. But what about this factor? Can I make, there's no extra 2's. I can't make a group of 3 factors of 2 here. So I can't take the cube root of that 2. I'm going to leave it written just as the cube root of 2. Right? This one I can't simplify down as an integer anymore. So here my answer is 2 times the cube root of 2. I hope that helps with square and cube roots, and we'll look at more of these together. Thanks so much for watching.